Okay, so the point of this little quick video is to go through how to add max and min gradients onto a graph in Loggerpro. Alright, so the experiment that I'm doing this for is this one. Okay, it's swinging a pendulum, measuring the tension in the string for different heights, and plotting a graph. Okay, back to Loggerpro. So these are my results, and you can see delta H is the independent variable. Alright, there's a couple of things that you can do here. Okay, if you click on the column, okay, you can open the column up and you can put in your Greek letters there, so that you can do delta H. You put your units in here, and if we go into options, you can see that you can change the number of decimal places or significant figures that the data is displayed to. Okay, and you can choose you know, how the error bars are going to be plotted. Okay, I've decided that I can measure the height to the nearest millimeter. Okay, so my change in height I can measure to the nearest 2 millimeters. Alright, so I'm all done with that. That's all good. Okay, and then when I was measuring tension, okay, I decided that the uncertainty, okay, because of the way that I was measuring it, some of the graphs, it was really clear exactly where it was. Okay, and I decided that I could measure that to the nearest 0.01 newtons. Alright, but some of the graphs it wasn't so clear. Okay, so that's why some of these values are higher. Okay, so what do I do with that? Well, I've typed them all up in a separate column. Okay, and then if I click on here, then you can see, okay, for the error bar calculations, okay, you just tell it which column that you want it to use. Okay, and you select that from the menu. Okay, so now it's plotting the error bars. You can see all of the X error bars, okay, are constant as we told it, and all the Y error bars, okay, depend on this column here. All right. So what do we do next? Okay, we need to plot a line of best fit through that. Okay, so we go to Analyze, okay, Linear Fit, okay, and tell it to plot a line of best fit. Alright, and we can move that around so that we can have a good look at it. And it, you know, it seems to be kind of off the bottom of the error bars, right? Oh, I know why. Okay, it's because of this outlier here. Alright, now that is so far away from the error bar, okay, that I'm pretty sure that that's an anomalous result. I mean, it's, you know, it's nowhere near the pattern of the rest of the data, so that must have just been me screwing up. Okay, so what I can do with that is just highlight that entire column, okay, and delete it, get rid of it. Okay, and you can see that it's automatically readjusted the linear fit, right? Okay, now if you go back to back to the experiment, okay, you'll see that what we're trying to do is we're trying to get a value for m, okay, and we can calculate a value now, all right, from the gradient of this graph. A little bit of rearrangement will get us the value of m. Okay, but the other thing that it would be great is if we could do is if we could get an uncertainty in m, right? And we're going to do that from the graph. Okay, so what we really need is like a maximum value that the gradient could be and a minimum value that the gradient could be, and that's really tough to do in Excel. Okay, so that's why we're analyzing our data in Loggerpro. Okay, let's have a look and see how to do that. Okay, go back to here, but instead of choosing a linear fit, we're going to choose model. All right, that's the linear equation. Okay, and if you look over here, okay, you can see what values it is for m and b at the moment. It's 0.9, okay, and it's about 0.7 ish, right? So I've just done this just to get this on the screen, as it were. Yeah, in fact, I'm going to pop it down there a little bit so that we can tell which one it is, right? Okay, so there's the one that I've just put on the screen. Okay, and at the moment you can see it's nowhere near any of the points. So what can we do about that? Double click on the box and choose Enable Line Drag, right? Okay, then you can grab hold of these handles, okay, and we want the let's do the minimum gradient first. So we stick that one there, okay, and that one there. Okay. Now for IB, it's enough that it touches the top of this error bar and the bottom of this error bar. Okay, you know that IB is quite happy with that as for the for you to calculate the maximum gradients. Okay, you know, you can probably spot that that's not the best estimate. All right, but IB is happy with that, so let's just go with that. All right, so that's got our minimum value of the gradient, okay, which we can read off there, yeah, and can compare it to that one. Now let's do the max value of the gradient. Exactly the same kind of technique here. Just get it on the graph so that you can see it, okay, and then double click on there, enable line drag, okay, and then we'll just stick it over here. Okay, and let's get it on the top of that error bar and on the bottom. Whoops. Dope. Let's work out what's going on with that. Oh dear. Let's try and undo that. Okay. Right, managed to undo that, great. So that one to the top of that one there, and I'm getting a bit confused as to which one it is. I think it's this one. Hallelujah. Okay. So now when I'm calculating M, the linear fit, okay, that's my best guess at what M's going to be. Okay, I can use that to calculate M. And then to get my minimum value of M, I'm going to use this value, and to get my maximum value of M, I'm going to use this value.